Hello, my name is Danut-Octavian Simion, and I'm PhD as, Associate Professor at Atheneum University in Bucharest, Romania. And I'll present my paper, Building Different Types of Object Using Data Within Economic Application, for MCHIS conference, which is held in 14-16 October, Athens, 2023. My paper presents a transformation and use of data into various types of objects within business web applications. Business models use different data sources and require successive transformation to include in various applications used within business enterprise. An efficient way of using heterogeneous data is to transform it into objects that can be used as templates in application built on basis of high-performance object-oriented programming languages. There are various challenges in case of large volumes of data accumulated within companies, which requires transformation into objects and templates, and when making the content available quickly and efficiently to users of various application modules. Data formatting is an important stage in their transformation in the case of large volumes of heterogeneous data, and then follows the stage of indexing and optimization for quick retrieval and easy use in various modules within applications. Complex business applications requires the retrieval operation for large volumes of data, which can be used for updating, implementation, and reporting. These operations requires fast retrieval of data across various types of patterns, even for large volumes of data, and depend on how to integrate into objects and content templates. The interconnection of data from different sources is a problem that can be solved by transforming data into objects and templates so that some common standards are respected that can be extended to large volumes of data. Complex business applications requires flexibility in handling and using data, and templating helps structure it into standard data types such as numbering, real, character, string, and item types structures. This transformation can be applied to large volumes of data using extraction, transforming and validation mechanism, so the data follows business rules and feed application modules continuously for high availability to all users. Mechanism for retrieving data represents presents in large volumes must be efficient and respect the structure of objects created as templates to instantiate values. These rules will ensure a specific standard for objects, and thus the paradigm specific to object-oriented languages can be applied, which ensures a high availability and flexibility necessary for economic applications that must comply with business rules. In my paper, I use some standard keywords such as business web applications, object templates, application modules, source of data for applications. For the introductions area, economic business applications require complex templates for different types of data, and from these points of view, transforming into objects that can be used by complex object-oriented languages is necessary. Current operational economic activities require the storage of large volume of data in different type of storage media, so that in any company appears heterogeneous data that requires complex integration operations within different modules specific to economic applications. The integration possibilities are specific to data types such as office, computing, files, databases, XML files, object-oriented class-specific files, and other different types of from different sources, requiring transformation and integration activities using complex methods that ensure common access in economic applications, but also an accuracy and constant updating necessary for the main modules of a business. Economic data flows requires data exchange within application modules, but also compatibility between types, so a single economic solution is not enough. The use of software services provides the necessary solutions for the exchange of data between different application modules, as it offers compatibility and utility, especially to objects programmed to perform different tasks. Object-oriented objects allow the creation of specialized software services for the exchange of data necessary for information flows within the economic applications for companies. A specific solution for heterogeneous data is XML files, which allow them to integrate into application modules and which can be the basis of data entries for object-oriented objects. These classes allow data entries in the specific types and format specific to the functionalities required for their integration into economic applications and software services or parsing transforming of XML files are integration solutions that allow great flexibility in exchanging data within streams. The economic applications allow the efficiency of activities within the companies by areas of activity and offer flexibility in achieving the specific objectives of different production programs, such sales, customer relations, suppliers, distribution, and external business environment of the companies. All companies have the problem of choosing best software solution, application, or economic information system, which allow customization or modification in accordance with the specific of each business. Choosing the software solutions is a difficult task and must take into account the specific of each company, but also the constraints regarding the price, reliability, the possibility of customize, or the opening of the system to the external business environment. Software services is the second part for data in business applications. These software services are optimally used in the design of the cost-effective applications that are easy to implement and maintain. Application development is highly optimized and also offers great diversity and flexibility in the use of various economic resources in an evolved way. The enterprise architecture for business applications has evolved far about the old-fashioned mainframe calculation through the client-server architecture from two tiers and to N level to software service oriented architecture. Software services have many features in common with service-oriented architecture, such as the focus on services and how services are disconnected from another service. Software has evolved around monoblock applications integration by exposing interfaces that rely primarily on general access to definitions, variables, and methods. Using middleware level as enterprise services can be configured basic architectures for software services. Software services are less complex, and even if they can use the message communication paths, which can only be used to transport messages and does not contain logic specific to business application, these application services are used for purposes that express applications logic. The single block representations allows the development of business components, such as the presentation of different flows, economic applications logic, business logic, and specific data access objects, and which are then grouped and archived specifically dedicated to deploy on the server architecture or are located in a content directory. In the single block representation, design is possible. Everything is included in one, namely the interface code, the business application logic, and the business application logic code, and the data access code, as well as the code that interacts with database-specific files, relational, or other activities. The service-based architecture has allowed application to be developed in a modular way where each software component can provide services to different components or entities outside the applications. Within the single block application, if different types of services and the application services are used with a certain representation component. In all of these services, certain representation components or other types are grouped together. The following model and design describes the software services. Within them, all components represent autonomy, and all components could be developed separately, built as new objects, implemented in custom modules, and tested independently. In this case, even the interface component in the application could also be a different client implementation that could use these services. The gateway applications provides a possible interface for different customers who can access individual services and who can solve problems such as what happens when we want to send a different answers for customers receiving the same service. For a reservation software services, it could send completely different answers to a certain mobile client, namely minimal information, but also a client for detailed information that offers different aspects and something different to a third client. For a software service, an answer may consist of data from two or more different services. Services can usually be a part of the same package in some scenarios where important services implementation could have their own modules, descriptions, and could form different applications, but grouped in a custom package. Interfaces for the design components are not always grouped together and have poorly defined coupling. For each software services that include its own modules and definitions and are grouped in a separate descriptions files. These activities have performed the services and offer their specific interfaces, such as products, sales, or store. These interfaces are always ready to be used. The user interface is implemented separately and designed using many services. This is the advantage over its single block counterpart. These are cases where the design and development of monoblock applications lead to a successful situation, such as e-commerce web applications. Large block applications, which are large when scaled, scale everything accordingly, namely all the components that are grouped together. In the case of a production raw material reservation application, a production, even if materials reservation services is to be scaled separately, the application should be extended and the reservation services cannot be implemented separately, thus not using resource optimally. Another downside is that scaling is one-dimensional. When there are multiple copies of extended application, will increase the volume transaction each time. Multiple program developers can adjust the number of copies for applications that used a server-based upload program or a remote station. Each of these files accesses the same data source, increasing the consumption of IT resources, and these results from all operations reduce the efficiency of the cache. Software services offer scaling flexibility only for the services in which this operation is required and the resources are optimally used to perform this activity. In this way, only one service can be scaled. For example, the raw material reservation service for products, and thus the other components of the application are not affected. Such an approach has an alternative extended version, and in this way, the transaction volume will not affect the applications, but also the data can be used by cache. The software development team carry out activities aimed at delivering new features and does not have to focus on issues specific to final application scaling. Software services can help in scaling in size of applications and development framework for people and products developed from a technical and economic point of view. In the next section, I used a package service written in Java, which has functions and the implementation of object-oriented code that can be used to implement and use a specific service for different type of applications, such as reservation. In the third part, I use the implementation of business objects, also written in Java, that has many objects that have these facilities and use their modularity. In conclusion, to easily build and use software services, we need to implement separate software services for each of the features of the economic application. If we want an online material reservation system for a warehouse, it can be divided into three main software services: warehouse services, reservation services, and user service. These diverse users of economic applications expect flexibility, multiple customization possibilities, and last but not least, performance in managing data specific to basic activities. Software services can model objects, classes that integrate superior features to multi-level applications and thus be used in various modules database or can be serialized to increase business performance and competitiveness. Thank you for watching this video. Hope to see you soon.